All right, the other thing we're going to look at for this review is solving some exponential equations. That's kind of the whole purpose of this whole chapter, is to be able to solve these equations. In particular, kind of ties some of the concepts that we've seen in the first chapter on introducing functions, particularly inverse functions, and the idea that inverse functions are generally used to solve equations. And so this review here is supposed to just introduce to you why we need that right now. So we're just going to solve some equations. They are exponential equations. So for each of these, x is the exponent. That's what makes an exponential function. And that's what we're going to see throughout a lot of this chapter. So for the first one, you might note 32 is a perfect power of x, perfect power of 2, sorry. All right, we know that 2 times 2 times 2 times 2 times 2 is 32. So we can say that's 2 to the 5. And so what we could write here then is 2 to the x equals 2 to the 5. And we haven't talked a lot about exponential functions yet, but we can do this cancellation property here with the bases. And we'll talk more about why we can do that so perfectly, and like why it doesn't always work for some of the operations we do, like squares and roots. But this perfect cancellation, there's only one solution to any of these questions. So our only solution is x equals 2. That's our answer. For the second one, maybe I'm just going to move some of this over. Let's see. Okay, so for the second one, just made myself some room there. Just touch on some of those exponent laws that I had mentioned before. That 0.25, that is actually a fraction. So this is a fraction. If you completely forget fractions, we could write this as 25 over 100, which does reduce to 1 over 4 in lowest terms. So 4 to the x is actually 1 over 4. And if you recall, that is the same thing as just writing 4 to the negative 1. So again, with the cancellation, negative 1 would be the solution to that equation. Now the C is a little bit trickier, but still doable. 243 is not a perfect power of 9, and it's obviously not going to be like a negative power of 9 because it's not a fraction. So it's not a perfect power of 9. However, it is a perfect power of 3. So this is 3 times 3 times 3 times 3 times 3. And in fact, what's nice about that is the fact that 9 is also a perfect power of 3. So what we could do is just rewrite both sides using base 3. So I have 3 squared to the x equals 3 to the 5. And then I will clean up my exponent rule here. That's my power rule of exponents. So the exponent becomes the product, 3 to the 2x equals 3 to the 5. And now my exponents, set them equal, just like I've done in the other questions, right? You can kind of cancel those bases. So 2 to the x is 5. And so what we get is x equals 5 over 2. And so if you've been keeping score, every single time here, I've been able to rewrite the numbers as powers of something that has something to do with the exponential part of the equation. That's obviously not always going to be the case. Like, not every number is a power of smaller numbers. So for example, on the right, we've got 7 to the x equals 57. 7 cannot be broken down into smaller powers. 7 is a prime. It can't be broken down into anything. 57, if I want to break down 57 into smaller components, that's 3 times 19. Yeah, that's its prime factorization, so we can't break it down any further. So obviously 57 is not a power of 7. And since 7 can't be broken down anymore, we're not going to get something like c. So we cannot write these both as a power with the same base. So what that means is that right now we can't solve this. We don't have the tools to solve this. That's our answer. We can make a bit of a guess. Yeah, so we can make a little bit of a guess. 7 squared is 49. 7 cubed, 49 times 7 should be 343. Yeah, 50 times 7 minus 7, so 343. So I know that x is somewhere between 2 and 3. Right? I'll write that as an interval. So if I wanted to write it as inequalities, I could write like this. I know that much, somewhere between 2 and 3, but I'm unable right now to narrow it down any better than that without using like horrible computational techniques of like, let's try. Yeah, I don't want to do anything more than that. We will learn in this section how to solve for this. So essentially what we're going to need to be able to solve this equation is we need to find some inverse of this function. Right, we need to find some way to cancel that 7 on the bottom. And so that's what we're going to get probably in next week's lessons. I think it comes in section 3.3. We'll introduce the logarithm, which is a family of functions that are going to do that for us. They're going to solve these equations for us, and they're very useful. So this is all we can do so far.